Okay, so we're going to talk about radian degree measure. This is very important. I'm going to say this every single day for trig. Very, very important. You cannot miss out on these notes. You need to know what's going on because this is going to be the key to us learning trig. Some real quick vocabulary words. You know what I'm talking about? If I were to talk about the initial side, so the initial side right here on this one is going to be the bottom. I'm just going to label it right here, initial side. It's always the bottom one right here, especially if we're graphing. This is always talking about, so like here's like a picture, right, of an axis. The initial side is always right here. This is always, of course, if I get the marker, it doesn't work that well. But this is always the initial side. We always start from there. When we start doing the unit circle and everything, it always starts from that side right there. Everything we do always starts from the initial side, and then however far open we go, that would be the terminal side. That's where it ends. So we start here, and we open it up, and then wherever we stop, that's where we end, and that is the terminal side. I know, right? I can't believe that these English words come true in math.
You know that little sign is like a standard deviation?
That?
Okay, you're in the legal. Mine looks like this.
Okay. Wrong class.
Sorry.
So essentially, it's in standard position is when the initial side is right here, which is everything we're going to do anyway. So this is standard position. So the vertex is at the origin. Everything we do is from here. So I don't worry about that too much. So positive angles rotate. How do they rotate? To the left, which is? Oh no, I guess spelled counter. Clockwise. Therefore, negative angles rotate clockwise. So if I'm going to come up here real quick just to get you familiar with how this works, is this would be 0 degrees, this is 90 degrees. Do you agree that if I were to open this up right there, give you 90 degrees, I'd give you 180? If I keep going, then we get 270. And if I put it all the way back there, I'm going to get 360. If I keep opening it up, like if I'm trying to take, I don't know, somebody's bone I don't like, their finger, and I just keep rotating it. If I keep rotating it, I know, the imagery is just amazing. That tells me you're listening. If I keep rotating it, so this could also, 90 could also be how many degrees? Could also be 450 degrees. I take that finger and I keep going. Could also be 540. That's not enough. Keep going. I got it there. 720. I'm gonna be done at 720. I then take his finger and I put it back. And I'm like, that's it. We're going the other way. If I go the other way, that's not too bad. That would be kind of 90. This is also negative 90. Take his finger. It's fine. It goes this way. Hurts a little bit. Not too much pain, but this would be. This is also negative 180 degrees. I take it. Oh, this is where it starts to hurt. Oh, and I get. And now he gives me his money, and I run away. I have successfully robbed. I think his finger is not going to make him die. I've successfully robbed somebody, and I go back. This is why trig is important.
Do you want to take someone's finger off?
Okay, so let's draw a 45-degree angle. So everything's in standard position. We're just going to draw just a terminal angle. So 40 degrees. Where would that be located?
Like this far away from straight up.
Do we know the quadrant names? Is that amazing that in the first quadrant we get from 0 to 90? That's where we start. That's the first thing we do. Isn't that amazing? And then we go into the second, and then the third, and then the fourth. So what quadrant is 40 degrees in? One. Oh, is it like halfway into one, or a little over, a little less? A little less. What negative 40? What quadrant am I in? Fourth, but from the standard position, am I a little bit more than half or a little bit less? A little bit less. Take that finger and go 400 degrees with it. Where do I end up? It's the same as the first one. Negative 400. Same as the second one. How did you know these were the same? Because Daniel said so, and the book of Daniel, we are done. Yeah, just subtract 360. You can add 360 or subtract 360 as much as you want with these degrees until you get to a number that you're more comfortable with. So if you're not comfortable with 400, you can either add or subtract until you know what you're comfortable with. So Daniel was like, I'll subtract it. He got 40. He's more comfortable with 40. So about quadrantal angles. Those are angles whose terminal sides land on either the x or the y axis. So that would be 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. You get the idea, right? They're all multiples of 90. If you notice, everything I do right now is all in degrees. I want to make you all comfortable. Pretty soon I'll make you uncomfortable. That's how you learn.
Are we splitting this packet in 2 days?
Are we? I don't think we are. Oh yeah, we had to spend like 20 minutes on that stupid book cover activity. Which was just me making fun of the book cover for 19 of the 20 minutes.
It really was.
Coterminal. Those are angles that have the same initial and terminal sides. Okay, so angles that have the same initial. So.
Why do they have the same terminal? How does that work? This is a lie.
This is a lie. Okay, so is 440, are they coterminal angles?
Yes.
Why are these coterminal? They're the same. So anybody's coterminal angle is just 360 degrees away in either direction. Are we questioning, debating, what's going on over there? You just said yes to an or question. I asked my child, do you want chicken nuggets or a hamburger? Yes! Usually that means hamburger. Usually the last one. Yes, these are coterminal right here. This is just like, so I can talk about, like, saying that, hey, these are... So just kind of ignore those pictures right now. Okay. So we talked about degrees and radians already. Circle activity now. I already did it. Let's just move on. So I kind of already talked about all this. Degrees versus radians. I already talked about it. So old times we did 360 degrees because we're trouble with degrees. But radians really just measures how many times the radius measures around the circle. So for instance, like right here is approximately 1 radian from here to here. So if this is r for radius, this length is about right there. I'm not perfect at drawing it, but that's about 1 radius. Okay. Oh, the challenge. Where would 1 radian be? Just did it. Where would 3 radians be? Right there, thank you. Almost to the end. So this is 1 radian. This is 2 radian. Where would 3 radians be? Where just did that? Where would 6 radians be?
A little bit away from that line.
This is 6 radians. Zoom into what? Air? What's up? Yeah, it should be a 3. Who said 2? Alright, why do you believe me? I'm not a very good one, so don't believe me. Let's not show Mr. Deuce this video. Yeah, you said that last time, it didn't happen. I forgot why, if you wanted to. But whatever.
I remember you exposing me to the YouTube internet.
What's that, Danielle? I exposed you? Alright, so you can convert from degrees to radians and from radians to degrees. You need to know these proportions. You need to know this. Okay? You need to know these. I'm going to come back to example 1. I'm going to go quickly do 2 and 3. I feel like it's a little out of order here. So let's go ahead and convert these angles from degree to radians. This is how you do it. You have to get rid of that units. How can you get rid of the units of angles? Divide by degrees. So we need, in order to get rid of this degrees, I need to divide by degrees. Let's divide by 180 degrees. In order to divide by 180, I have to multiply by something. What's an equivalent to 180 degrees? In radians. Times pi. So for all of these, we have to divide by a degree value to get rid of the degrees. Every single time you need to get rid of degrees, yes. Every single time. Yes, you could do other things if you wanted to, but it would be a little more complicated. So the whole point is, I don't want you to be memorizing, okay, if it's a degree, I'm going to memorize. I have to divide by 180 multiplied by pi. Don't memorize it, understand it. You're trying to get rid of the degree. How do you get rid of the degree? Divide by a degree. What's a degree measure that you're comfortable with? You're comfortable with 180 because 180 degrees equals how many radians?
1.
Pi radians. Not 1, it's pi. So that's why I'm dividing by 180 degrees and multiplying by pi. So how does this simplify right here? What's 60 over?
1/3 per what? Is that because are we dividing by 180 and multiplying by pi because that's 1 radian equals 180 over pi?
That is correct.
And we have to get pi out of the denominator.
What you said will work, but that's not actually why we do it. But sure.
Can I say that's why we do it now? Yeah.
No, we need to divide by degrees. Have you ever converted anything from like feet to miles?
No.
To do that, you need to divide by feet to get rid of feet.
Yeah, we know. Yeah, so you have to multiply by pi to get rid of chemistry.
I know what you're saying now. I get what you're saying now. Yeah, you're correct. I get what you're saying. You're correct. So this is equal to, how does 60 over 180 simplify?
1/3.
So it's 1/3 pi. We write this as pi over 3. Try B and C on your own.
No. Wait. Why isn't there pi in the bottom line? Oh, never mind. No, answer that.
I don't answer stupid questions anyway. Try B and C on your own.
Oh my god, I've been doing the wrong one.
You've been doing number 1?
Yeah, I was looking at 100.
we're not doing that. Alright, what do we get for B? 16 pi over 9. What do we get for C? Alright, so hey, real quick, we do not label radians, okay? We do not label radians. There's like an imaginary R here. We just never do. We label degrees, you don't label radians. That's just how the world works. So, if you want to put an R here for giggles, you can. You don't have to. But it might kind of help you for this third one right here. So, to convert from radian to degree, you have to do the reciprocal. So, you have to divide by and multiply by 180. So, it's easier right out this way. For this one. Why is it easier to out this way? Because the pi's cancel out and you're left with 180 over 6, which is 30. Try B on your own. Alright, so for B we got 300 degrees. This is kind of a weird one. This one's in radians. It just says 3 radians. So, again, I need to do the same thing. I need to divide by and multiply by 180. It's just, answer's going to look weird. Okay, so what's on top? 540 over pi degrees. Yes, because you're not going to have a calculator for this. So you can leave it like this. But for someone that does have a calculator in front of them, what is, so we can kind of understand what this is about. What is, it should be kind of close to 180, because remember? So it's 171. So if you want to know, this is about 171 degrees, just as a little bit of an estimate. You should already know that because of our little fun activity. We didn't do number 1, so let's go back up there and sketch real quick. So the first one, easy to sketch, 100 degrees in standard position. So I always draw this. This one's going to be in the second quadrant. So compared to this line right here, is it when it's halfway, is it more than half, less than half? Okay, comparing it to this, so it would be more than half. So it'd be like pretty close to here. I always compare from the x-axis. Everything I do is always from the x-axis. Just so you know where my brain is at all times. What, negative 4 pi over 7? Alright, we gotta get you comfortable with this. Well, it's negative, so what direction do I go in? So, 4 pi over 7, so it's really 4/7 pi. So pi is 180, so is this more than 180 or less than 180? Alright, it's less than 180. Okay? Okay, so just try to get you to think through this. So 4/7 is less than just 1 pi. So I'm not going quite to 180. So I'm somewhere here. Because I know I'm going clockwise, I'm somewhere here. Okay? Now, if this is pi and this is half of pi, let's figure this out. 4/7. Is that bigger than half or less than half? How, like, much bigger or a little bit bigger? Just a little bit bigger. So it's just a little bit bigger. Right there. These are estimates. Just deal with it. Try seeing your own real quick. Use your brain. Think through it a little bit. Just think, okay, is this more than pi, less than pi? Okay, is it more than half a pi, less than half a pi, or more than whatever? So 3/5 pi, is that more than pi, less than pi? And again, I'm positive, so I'm up here somewhere. And is it more than a half, less than a half? A smidgen more than half. So it's about that, give or take. Don't you just love trig? Yeah, we're just like scratching the surface of all the great fun that is coming around the corner. Oh my god. Okay, coterminal angles. We just kind of talked about this a little bit. Coterminal angles are when you add 360 degrees or subtract 360 degrees. So if I give you a problem in degrees, I want the answer in degrees. If I give you a problem in radians, I want the answer in radians. So here's some examples. So to find coterminal angles, you would add 360 or whatever, or subtract 360. If I'm in radians, I would add 2 pi, or I subtract 2 pi. So, find coterminal angles. They want one that's positive and one that's negative. That just means add 360, subtract 360. So if I add 360 to this guy right here,
I'll get 360.
396 degrees. And if I subtract it, negative what? Somebody? 324? Do the same thing for B. Plus or minus 360 degrees. That's going to give me 150 and... Okay, for C, what do I add and subtract? So 2 pi. Now, this kind of looks difficult. Like, I don't want to add 2 pi, so let's just make common denominator. Where would the common denominator be? So it would be on top. So 8 pi over 4. I need one positive, one negative. Is this plus or minus? Can they give me my one negative, though? It actually doesn't. That's a shame. But can I add it to get another one? Yeah, let's go ahead and add. What do we get here? 17 pi over 4. If I subtract it, what do I get? I get pi over 4.
Is that okay?
That answer would be okay. I would take either one of these. 17 pi over 4 or pi over 4. But do I have a negative one yet? So I need to do what again? Subtract another 8 pi. Very good, everybody. Good teamwork. Try D on your own. What two answers did we get? I hear 7 pi over 6. Are there more correct answers, by the way?
Yeah.
How many correct answers are there? Infinite. You can put any answer you want as long as it's correct. Now, if you're that jerk that's like, oh, I'm just going to put like negative 41 pi over 6. No, I'm correct. And I have to figure it out. You're going to make me mad. Don't make me mad. Just find the closest ones, please. Now, if you think I'm stifling your creativity, you're just a jerk. Alright, we cool here? I talked about everything else that's on here, so let's just do the very last thing, talk about arc length. And we talked about this already a little bit that's how we measure. We measure arc length in terms of radians. So for a circle, we need everything in radians. We cannot measure arc length with degrees. So, did they seriously have the formula hole punched over? It's okay. I read it this way anyway. S equals theta r SOR. Ew. Theta needs to be in radians. Otherwise, you can't measure. Degrees don't help us measure anything in terms of arc length. So it needs to be in radians. So here we go. Example 5. We have a circle of 27 inches. Find the length of the arc intercepted by a central angle of 160 degrees. I'm going to give you a little bit of a visual here, what we're trying to do. So here's a circle. This is the same circle I always draw, because that's always in our standard form. It's always my initial. And where would 360 be? 160? Yeah, 160. You know what I meant. Like over here-ish? Yeah. Okay. So I need to find, I'm kind of darkening it, that length right there. So this is 27, and then so, let's figure how much that is. And we can kind of know if we're going to have the correct answer or not, because how much is just a quarter of this circle? What should the length be? That quarter of a circle. 1 radian of the circle, which is about right here. That should be about 27, right? Right here's about 27. So right here, it looks like it's about another 27. Looks like it should be about 54. Maybe probably a little more than 54, because I can't draw. 54, 60, maybe in the 60s, possibly in the 70s. I don't really know. I just can't draw very well, but we'll see. Let's figure it out! Well, I have 160 degrees. I can't work with that. What do I need to do?
Divide by 180 and multiply by pi.
So it becomes... So theta is 8 pi over 9. So if S equals 8 pi over 9 times 27, which is 24 pi. Because 9, this 27 cancels out into that 9. We usually leave the answers in this. No, we're just going to leave everything in terms of pi.
Are we going to have a calculator? Yeah.
Where does it say, where do you see the word calculator?
I'll just go check.
Oh, yeah, I mean, but there'll be some times where it'll be in terms of pi. I want you comfortable with answers in terms of pi.
But how to get 24 is what I'm saying. I didn't even know this.
Okay.
Divide both sides by 9. Shut up.
Wow, let's not be rude to each other.
I'm talking to Carson. We're dating.
I think you need to.
That's really rude.
Yeah, well, pay attention. So 9 goes into 27 3 times, and then 3 times 8 is 24. Okay. Let's move on. Last example, and then I'm done talking to you people until the weekend is over. Area of a sector. Here's the formula. It should look somewhat familiar, because what's the area of a circle? It's pi r squared, right? So that's where the r squared comes from, and then this is just 1/2 pi. It's 1/2 1/2 theta because it's trying to just narrow down a certain sector of the actual circle. So this is the area. Again, I'm not a big fan of memorizing. I just understand how it works. Like, oh, you can find the area of the circle and then tell me how do you want 1/3 of the circle? Do you want 1/4 of the circle? Whatever. So that's really where that formula comes from. So we have a sprinkler in a golf course is set to spray over a distance of 75 feet and rotates through an angle of 135 degrees. Find the area of the fairway watered by the sprinkler. All right. So anybody here dreams to work on a golf course?
Yeah.
Yes.
I've always said it.
Okay. So this is the problem for you. This is applicable. You want to know how much water you're using or whatever, and you need to determine that by knowing how much area is being covered.
Okay.
So what do I do here? I'm not asking just you.
Draw
but
it.
draw. Sure. Let's draw. Let's see it. So this is 75, and 135 is probably right there, correct? So I need to know this area. Okay?
So, yes, 135.
So let's get 135 into,
135.
yeah. So what is this in radians? 3 pi over 4? That's pretty quick. Or did you do it?
Calculator. No
Wow, are you just blowing her in right there?
There's no way she's that.
You're gonna get fluent on this. Trust me, it will happen. We're gonna do this so often you're gonna get fluent. If you don't get fluent, I'll see you at retake time. Okay? No problem. You need to get fluent at this. So the formula is A equals 1/2 R squared, which is very good, class, 75. This one you're gonna need a calculator for. Times get this I want it in terms of pi though. I want it in terms of pi. So multiply everything except for pi. What do we get? After this, I'm going to show you another way to do it, which might be easier for you all. What did we get? 2109? 0.375 pi? Say it one more time because I was not listening.
That's what I got.
Can we convert that to a fraction real quick? 209 and 3/8. Alright, whatever. You know what? You're all losers. What do I care? Alright, that's fine. I'll take this answer. Yeah, unless it says you get to do fractions. But I'm fine with it. Because it's such a huge number, it's kind of awkward, so I'm fine with that. Also, you can multiply by pi to find out the more understandable answer. Here's another way to do this problem, by the way. So, another way to do it is you can find the area of the entire circle. How would you find the area of the entire circle? So, area of the entire circle, I'm going to put a little O down there, saying like the entire circle, is going to be pi r squared. But do I want the entire circle? No. How much of the circle do I have? I have 135 of it out of 360 of them. Times this pi, 75 squared. And you're going to get the exact same answer. It's just a different way to think about it. I'm just trying to help you not have to memorize these things. Okay? I understand I'm trying to be like, hey, do radians, do radians, do radians, but I mean, let's just use common sense here. If we can figure out that this right here is about, it's 3/4 of the, or not in this case, it'd be 3/8. If this is actually like 3/8 or whatever of the entire circle, well then just find the area, multiply by 3/8. Questions, comments, concerns?